Hello and welcome to York Universe, the astronomy and astrophysics radio podcast written and presented by students, faculty, alumni, and friends of York University. You'll find us now wherever podcasts are distributed. I'll be one of your hosts this evening. I'm Dr. Elena Hyde, and I'm joined by a special guest who I will be introducing shortly. We are broadcasting live from the Allan Carswell Observatory, located at York University in Toronto, Ontario, Canada. Just as a reminder, York Universe broadcasts live every Monday night at 9 p.m. local Toronto time, or approximately 2 a.m. UT if that's more your speed. We broadcast on YouTube live at York U Observatory in concert with the online public viewing program run by the amazing observatory team. They're responsible for all the visuals. Now, of course, the podcast audio goes out to Amazon and Spotify and all those good places. So you will find the audio, all kinds of extra stuff as well, also on Libsyn. So if you want to get the full list, you can go to our website, yorku.ca/science/observatory, and follow the links to York Universe, or you can actually follow the links to OPV online public viewing and join the live chat on YouTube. If you have any questions or comments about past shows, suggestions for future topics, or just general inquiries, you can email us at observe@yorku.ca. You'll also find us on the social media. We're on Instagram at YorkU Observatory, Facebook at LNI Carswell Obs, and PixelFed over on the Fediverse at LNI Carswell Observatory. All of our programs, including this one, are free, but we do love to get donations to run extra programs as much as we can. If you'd like to make a donation, you can see that same website I mentioned before, yorku.ca/science/observatory, and then just scroll down to the donate section. If you are live on YouTube right now, please be aware that you can ask questions in the chat. Our crew is monitoring for the chat room and, of course, going to post some fun content. And now I'm going to talk a little bit about our fun show for tonight. So I'm joined by a special guest, Mahesh Aravamudan, a RASC Toronto Centre member and an astronomy enthusiast. Welcome, Mahesh.
Thank you, Elena. How are you doing?
I was looking at the skies, and it does seem like it is a little bit too cloudy to open up the 1 meter telescope. How are the skies where you are?
Well, it's cloudy here as well, so I was waiting to see the little bit of a full moon, which happened yesterday. I was trying to get that, but it's missing right now.
Yeah, the clouds, if they're thick enough, they will do that. Now, I will just go ahead and actually put a little extra advertisement. I will be posted on our social media at the Allan I Carswell Observatory, I believe this week. But if you missed it, on our website, we now have a publicly accessible all-sky camera. So when I tell you that it's a little bit too cloudy and hazy to open the domes, you don't have to take my word for it. You can actually go to yorku.ca/science/observatory and then click on Observers to get all of the observers tools. And there's a all sky camera view embedded on the page, and you click on it and refresh it to get the most current image. And just a little pro tip, the thumbnail is not the most current image. So if you do like to spy on telescopes, it's a wonderful little tool. And we finally got the all sky camera, knock on wood, but it seems to be working. So I hope everyone has a fun time enjoying the telescope images. Of course, next time it is clear, you will be able to see the domes spin around and maybe even see the telescopes peek out through the all-sky camera. So a bit of extra fun for, I suppose, telescope enthusiasts in particular.
Elena, if I can comment here, thank you for inviting me, but I have followed you for the last couple of years, done some very wonderful work with York University in terms of the observatories. So it's a privilege to be here to listen to this lecture. Just wanted to mention that.
Oh yeah, well it's great to have you here too. As I was telling someone else, there's just no fun if you're talking to yourself.
Ah,
It's
I will
it's so
chime
much
in.
yes, it's so much more fun to do these shows when you have someone to talk to about great space stuff that's going on. And you know, if we can make some fun tools to make a few more astronomers happy, I'll call it a job well done. Um, Now, of course, we're talking about cloudy skies tonight in Toronto, Ontario. But if you are outside of Toronto or outside of Ontario, you might have clear skies. In which case, there's a lot of fun things that you can try to look at. If you're in the northern hemisphere, there's a couple good planets, and we'll talk, I think, a little bit more about the moon later in this broadcast. But I thought what would be fun is, I'll go ahead and take our guests with me on a little bit of a jaunt through history. So usually we start off York Universe with a bit of this week in fun history. So we have a couple fun ones. And we're going to cheat a little bit with the first one. So usually we do, happy birthday shout outs, but one I just had to put in was Sandra Faber, born in Boston. Now, she was born on December 28th, which is after we're going to be done and taking our break for the Christmas period. So I'm going to put her in now because she's awesome. She's an astrophysicist and she was born on December 28th, but all the way back in 1944. So we just have to sort of mentally do the arithmetic. Um,
Amazing.
Sandra Faber, a very accomplished astrophysicist, she focused on the evolution of galaxies for her research, which of course I do happen to identify with a little bit because I am a big galactic archaeology fan. I love looking at how galaxies form and what kind of interesting structures they can have. So her work was always a big favorite of mine. Um, she, of course, had a lot of accolades. She was a university professor in the United States at the University of California, Santa Cruz, and worked at the amazing Lick Observatory, which I don't know if everyone is familiar with Lick Observatory, but it's a historical observatory in the US, in California. And the Lick Observatory has a wonderful visitor center that you can actually go into. And since about 1888, it's had research running. So it has a great mix of historical telescopes as well as modern research telescopes. And if you ever get a chance, I do recommend going there and checking out some of their historical telescopes in particular. It's quite captivating, I suppose you might say. So she was at Lick Observatory in 1944, at which point those historical telescopes were a little more current, and some of the current ones weren't there yet.
Yeah, and I hear she's the first woman on staff as well, right? That must have been a trailblazer, actually. Must have been very interesting. Yeah.
Yes, and there were a lot of firsts for women in astronomy in California. Actually, it's a whole thing. In particular, her research on galaxies led to linking the brightness of galaxies to the speed of the stars within them, and she was the co-discoverer of what's called the Faber-Jackson relation. This experience with telescopes and astronomy led her into design of telescopes, which is another thing that I find really fascinating because if you love mechanical engineering, electrical engineering, optical engineering, telescopes are going to absolutely be your jam. And she was instrumental in designing the two Keck telescopes in Hawaii. So another great one to look up if you haven't had a chance to look at some of the schematics from the Keck telescopes. Also, really fun. Um, She, of course, did a lot more than that with her rather glorious career. She studied at Swarthmore College, did physics and mathematics and astronomy. She got her bachelor's degree in 1966 and her PhD in 1972 at Harvard University, specializing in optical observational astronomy. And at 1972, it was still a very, very different world for astronomers. We didn't have the modernized, small, light, and easy equipment that we have now, which is sometimes still pretty heavy. The only observatory open to her at that time in 1972 was Kitt Peak. And that observatory is also one of my own favorites. It's one that I got to use as an undergraduate. So Kitt Peak in Arizona is a famous mountaintop, which has a variety of really, really fabulous telescopes. It's got a absolutely astonishing solar scope and a whole array of really wonderful optical telescopes as well as radio dishes and all kinds of other things. I'll just tell you my own perfect favorite is the Bok telescope because it has the most wonderful submarine door to get out and look at the skies through.
Mhm.
The Bok telescope is also, of course, very, very good for spectroscopy as well as photometry. And yeah, there are two radio telescopes up there as well, but I never really spent much time with the radio. Much like our history astrophysicist Sandra Faber, I have always been drawn back to optical. So she, of course, went on, as you said, the first woman on staff at Lick Observatory in 1972. And she looked at the relationship between the spectra of galaxies and their brightness, orbital speeds, motions, looking at how stars move within different kinds of galaxies, and the resulting law governing the movement of galaxies is the Faber-Jackson relation, which is, named for her and her co-author, a graduate student, Robert Jackson. She went
But
in, yeah,
it's so it's so interesting. Sorry to, it's
yeah,
so interesting that in 1972, the spectra of galaxies, she was able to find the statistical dispersion of velocities of stars in a galaxy, right? And then somehow correlate that to the luminosity, right? So that's the relationship. But that was interesting that it was that advanced in 1972, was it, or 1976, was it?
yeah. And I mean, we were getting relatively, well, the highest accuracy that had ever been seen up to
Uh,
that point, but it was enough to measure a reasonable amount of galaxies. Obviously, the James Webb Space Telescope is putting all previous distant galaxy measurements to shame. Um,
right.
but but at the time, it was really cutting edge what she was doing, and
Yeah.
looking at, of course, the absolute magnitude or the luminosity coming out of that galaxy and the velocity dispersion, which is the spread of velocities, the how different are the velocities in the galaxy, and
Oh,
looking at that
that's
relationship, it's almost you know, it's a quick mathematical relationship that you can actually plot up. And she was able to get it experimentally. And then, of course, they were able to write up a formula for it, which we still use today.
no. What fascinates me is, I believe if my understanding is correct, that it's the stars within the galaxies, how fast they are going around, right? And she was able to measure that. Is that correct?
Yeah.
Is
And so
that?
your velocity dispersion is a little bit like um, if you had bees buzzing around a hive, how fast would they be going, sort of thing.
And she was able to say that with the Doppler shift and things like that, right? So is that through spectrograph?
Yeah, so if you have the spectrograph, what she was looking at would be things like the velocity measurements from certain absorption and emission lines. So you look towards a line that you know what it's doing, and then you see it shifted, and you can get the real radial velocity of that object.
That's
But
amazing.
yes, it's a
1976.
yeah, exactly. And of course, being a very accomplished astrophysicist, she wasn't done there because she then went on to publish a paper for the evidence for the existence of dark matter.
That's
And so,
amazing. I thought dark matter came into being in 2000, after 2000, but
no,
now I
this was
know.
this was 1979. So she was already publishing about dark matter. And in 1982, she followed up showing that dark matter could not be composed of fast-moving neutrinos. So they never really knew about neutrinos and their very low mass. It was a reasonable thing to consider, could dark matter be neutrinos? But she was actually able to show that probably not. It's likely made of slow-moving particles that have yet to be discovered. So of course, this set off a huge mystery, and she collaborated with a whole bunch of people, Joel Primack, George Blumenthal, and Martin Rees, about how dark matter is part of galaxy formation and why we need it, but also how is it part of how galaxies evolve? So not just their creation, but how they change over time. And the first proposal of evolution of galaxies from the Big Bang on up was developed by her and those collaborators. So of course they needed more observing to help with this. And the construction of the Keck telescope with the first wide field planetary camera for Hubble Space Telescope was a high priority. So Keck is I think it's still the second largest optical telescope. Its primary mirror is 10 meters and it's made of 36 hexagonal segments. There have been a bit of a race to the top in terms of largest telescopes, but since Keck has two eyes, there are two telescopes next to each other. I'll count it as still one of the best because of its location, its adaptive optics, and of course the fact that there are two of them.
It's
Um,
in Hawaii, right? It's in Hawaii.
yes, it's on the
Wow.
large island of Hawaii, and it is it's that one's a little harder to get up to. You believe you are supposed to wear oxygen to go up there
Yeah.
because if you want to
Yeah.
get up the mountain for that one, the Keck Observatory is, was it 4,000 meters
Yeah. I
or
trekked
more?
up there. Yeah, I went up there and it's amazing. Yeah, I had to walk a few steps and I was out of oxygen, right, for a while. It's, it's
Exactly. Well,
amazing.
that's you have to watch out for altitude sickness if you're coming up from the ground level to the telescopes. You change your altitude by so much, you could actually get altitude sickness and have to be carted off by an ambulance if you're not careful.
Mm,
I know when I went up, they offered oxygen, and I was like, you know what? I'll
correct.
just walk around with that.
They make you get used to it 10,000 feet or something like that, and then they take you up there, and then still you're still out of oxygen, I suppose, right? So it's amazing.
Yeah, and it depends on how long you stay, at how long you adjust. And there is I believe they call it a sort of a, what was it, the warm room, or I forget what they called the little house that they
Yep.
put part way up the mountain. It's a little bit of trivia for our listeners. I'm sure somebody remembers the name. But yes, you can sleep there as well instead of going all the way back down to Waimea. But great fun, and of course, Keck Telescope getting great amounts of use when it was first brought on. Faber co-chaired that science steering committee which oversaw the first light instruments for Keck 1 and worked on Keck 2 as well. So those are the two different telescopes up there. And yeah, you can imagine how exciting that must have been at
Yeah, it
first light
is.
on Keck. In the 80s, of course, she was also involved in the Seven Samurai project, which aimed to catalog size and orbital speeds of 400 galaxies in 8 years. If you're doing them one by one, this is a lot. They didn't actually quite meet the target, but the group developed a way to estimate the distance, and this is the cool part, to any galaxy. And this was a new development, which really led to a lot of people realizing that the universe is just continues to be much bigger than we're prepared to try to picture. So she assisted with the camera for the Hubble Space Telescope, and if folks remember from our previous episode, when Hubble launched, it did have a little bit of trouble because it was launched with a little bit of spherical aberration. And it had to be fixed by astronauts. And who helped diagnose the cause of the spherical aberration? Well, that was also Sandra Faber.
She
So
put the
very
specs on the Hubble.
Yes, well, she helped certainly, and she was a university professor at UCSC in 1995, principal investigator on a nuclear team, which used Hubble Space Telescope to search for supermassive black holes at the center of galaxies, and a little bit of something for our survey fans. She was part of the Candles Project, which is the largest survey of the universe taken by Hubble. And she became interim director at University of California Observatories in 2012 and was co-editor on the annual review for astronomy and astrophysics from 2012 all the way until 2021. So all the way till basically current day, almost. Um, so she
Hey,
is she is currently aged 80 and a very accomplished astrophysicist. So a little bit of a early happy birthday to her because her
amazing.
birthday is when we're off air.
Amazing. Yeah, that's amazing to see how much she has done in those 80 years, and the accomplishments are amazing.
Yeah, it's always it's nice to see that, sometimes you are able to follow a project to completion. Being part of the team that helped Keck come into being, helped Hubble come into being, and then getting to use that data, amazing. And of course, big shout out to her for her birthday.
Is the Candles project still going on, or it was between 20, somewhere in the early 2011, 2012 time frame, right? If I remember right. Has it been stopped, or is it still going? The largest survey of universe.
You know what? That is a good question. I know that Hubble is definitely still going.
Right, yeah, I know.
Um, and I think the Candles project has branched out. They had a legacy survey, and I don't know that they have um, completely stopped. I think that they've kind of gone into a special mode. So last I heard, they were running MAST.
Okay.
And this might have been a little bit ago, but it was specifically targeting certain redshifts to look at early points of galaxy evolution. So I want to look at specifically galaxies in the redshift of 8 or something.
Yeah. That they have an animated GIF or something like that. Like they have put all these things together that you travel 6 billion light years, and then these galaxies whiz past you in on the NASA website. So that was I've seen that way back where I've seen that image. They have actually stitched stitched it together, and then you can see all these galaxies coming at you and going. And as you go further and further, it becomes redder and redder, right? So to show the
Yeah.
redshift, that's an excellent animation, right? So I thought,
Yeah, they do have enough data now that you can get some really wonderful animations and visuals. And the survey, looking at what they call the cosmic dawn, it's basically less than 1 billion years after the Big Bang, which seems like a lot of time, but then you have to realize that the universe is also pretty old. So if you want to get less than 1 billion years after the Big Bang, you're looking at the first seeds of cosmic structure in the universe. And so it's very, very exciting. Wonderful project. All right, so let's do one more. This one's going to be a little bit quicker, but no less awesome, I suppose. Uh, now, this is This Week in History because yesterday was December 7th. But if we want to go to a similar frame of time, we can go December 7th, 1968. So, in the realm of the years we were just talking about, there was another interesting astronomical observatory out there, the Orbiting Astronomical Observatory. And this December 7th, 1968 was the launch of Orbiting Astronomical Observatory number 2. It was also called OAO2, Stargazer. Stargazer is a much better name, I think, than OAO, but they had to have an acronym, I guess. So this was the first successful space telescope. The first one that they tried was OAO1. So it was an orbiting astronomical observatory number 1, but that one did not operate. So it doesn't get special mention. It's, it,
second try they got it, right? So that's
yes,
good.
on the second try. So yeah, not too bad. I mean, obviously, no one wants to lose an orbiting observatory.
In
Um,
1968, that too, right? So it's amazing. Yeah.
yes, exactly. So this successful observatory looked at comets, planets, galaxies. It looked in the ultraviolet, so it looked outside of the visible range. Um, and it had two major instruments, which were actually set facing in opposite directions. So you could look at in two directions at two different things at the same time, which was an odd choice, I thought. But I didn't design this observatory, so it had some advantages. The instruments that they picked were the Smithsonian Astrophysical Observatory (SAO), which you might have remembered if you've ever done any data analysis. The SAO has a whole bunch of data reduction
Right.
tools.
That's true. Yeah.
It's still in use today, so keep in mind. And we're talking 1968. So, anyways, the SAO and the Wisconsin Experiment Package, or WEP, WEP, they discovered a large halo of hydrogen gas around the comet Tago-Sato Kosaka, which was observed in 1970, so just 2 years after it launched. And SAO, or which was also called Telescope because they wanted a better name for it, had four, and this is a little bit hard to picture. This had four 12-inch telescopes. So this is a foot or approximately a third of a meter. This is small, right?
Right. Yeah.
And they fed into a UV light detector that converted your light into electrons. And the electrons then had to be converted into voltage. And this is an interesting design because if you think about how we look at the universe today, we mostly use CCD silicon detectors. But
Right.
when you have different wavelengths and you have, go back in time, some very interesting technology was used.
Yeah, no, yeah, CCD was invented later, and it's amazing in 1968, right? I believe it was based on some tube technology that they used, right, at that point in time.
Yeah, it was a kind of well, it was literally just four 12-inch telescopes. So those were your tubes that were bringing your UV light in. And then you had to convert that light into electrons, which then convert it into voltage. The
Right.
detectors gradually lost sensitivity, so they couldn't keep running it indefinitely because of how they were set up. So it had to be shut off in April of 1970. But while it was active, they cataloged about 5,068 ultraviolet stars or ultraviolet bright stars, covering about 10% of the sky, which you can't do very well from Earth because our atmosphere blocks a lot of this light coming in.
True.
Um,
Yeah.
so the Wisconsin experiment package, the WEP, had 7 telescopes, and they observed over 1,200 targets before their mission ended in 1973. So the Orbiting Astronomical Observatory 2,
Mhm.
it kind of was uh, a collection of really interesting packages and um, and abilities and facilities. It was built in the shape of a little bit of like an octagonal prism, so an eight-sided um, prism shape. And then they tried to sort of, stick all the instruments inside. There are some pictures out there you can find of the original before its launch. I always recommend people to go and look at some of these older instruments and older telescopes just because the designs are so different from what we have today.
It's yeah. So this was a predecessor to Hubble and a few other telescopes in space. I take it, right? So this was like a trial run in 1968.
Yeah, and there were quite a few different sort of, I suppose, observatories that tried to get through. And it's interesting, of course, because the ultraviolet light in particular, um, I believe it used VidCons, which was
Oh, yeah.
a Vidicon was based on the television technology. Um,
The cube
so
technology,
yeah,
right? Yeah.
the television tube technology. So it had a cathode at one end and kind of a camera lens at the other end and a telescope tube in the middle.
Yeah, I remember studying that in my first electronic course, something very similar. Yeah, okay.
Yeah, so really, really interesting design. And of course, not being able to see a lot of the ultraviolet from Earth is actually a good thing. I would just go ahead and remind our listeners because
Yes.
ultraviolet radiation is a very, very hazardous form of light. It causes DNA damage, it blinds eyes, it causes triggers skin cancers. So without our wonderful ozone layer, especially absorbing this stuff, life as we know it would have a very, very tough time.
People would
Um,
remember COVID, right? So a lot of ultraviolet was used to kill the germs, right?
yes. Well, and I
But
mean, of course, we used to have that hole in the ozone layer where ultraviolet radiation would come through in higher levels, and of course, a lot of skin cancer happened from that. I moved to Canada from Australia, so I know about
oh yes,
the,
yeah,
the wonders of sunblock. But not exposing yourself to ultraviolet light is a fabulous idea, unless, of course, you
research.
are a fabulous observatory, like the Orbiting Astronomical Observatory 2, which was launched back in 1968. All right. So that's all I have to say about the wonderful observatory. I do recommend people to go and look it up and have fun investigating it. I do have just a couple reminders since we're about halfway through the show. I would like to thank everyone for listening to York Universe. We are broadcasting live from the Allan I. Carswell Observatory which does now have an all-sky camera on its website, so you can follow along and look at yorku.ca/science/observatory /observers if you want to see the all sky camera, and you'll notice the sky is cloudy. So we're showing beautiful archival images over on YouTube. And if you'd like to ask any questions, the YouTube chat is, of course, open. Tonight, you are listening to Dr. Elena Hyde and, of course, my special guest, Mahesh Aravamundan, a RASC Toronto Centre member and astronomy enthusiast, helping me out this evening. So, Mahesh, we've covered all the history that we're going to cover today.
Oh,
Um,
lovely, Elena. Like, yeah, actually, see some of the things that, yeah, about Sandra Faber. I didn't know about it at all, right? So thanks for bringing it to light. And so it's amazing, like what the work she has done. We all hear about the big names, Einstein and others, and so, but there are other people whom common people don't even know. So much of work has been done in terms of astrophysics. So this is excellent, like what you have brought out. And I never knew about this OAO-2 stargazer. So that's another learning experience. Thank you.
Yes, absolutely, and it's all fun stuff. Now, this is the part where I would normally also say the news, so I'll give you a little update for the Allan Carswell Observatory. Please note, everyone, that we do have a tour on December 17th. However, after that, we are breaking for the holidays until January 14th, so there will not be any in-person tours during the break. However, if you would like to pick up our new 2026 observatory calendars, I have heard they do make wonderful gifts and they are on sale now at the York University bookstore and in person at the Physics and Astronomy department at York University. It's the first floor, just go to the main office and you'll be able to buy them there. I thought I would go ahead and mention there is an extra event since we have a guest from RASC Toronto Centre. The RASC Toronto Centre DDO Speakers Night is also coming up, I believe December 12th,
Well,
for anyone else who would like to follow along.
and there are so many events that, thanks to Dr. Elena Hyde, we have been able to, RAS Center has been able to do a lot of speakers night. But there are so many events organized by RASC Toronto around the GTA area. Just check it out on your website and you will see excellent, like, recreational astronomy nights, speakers nights by some of the top speakers in this area, in this field. So there are so many activities regionally, like watching, sky gazing, and DDO has a lot of David Dunlop Observatory in Richmond Hill has a lot of activities as well. So there's a lot of scope for having fun with astronomy. I joined RASC about 15 years ago. I've never regretted it. All right. Though I'm not a regular visitor, but I still enjoy whenever I visit DDO or York University Observatory or the other places that organizes RASC events. So there must be something near your area as well. So just check it out. I just
Yes, and
added
of
to
course,
it. Ellen.
if folks are not in Ontario, please do not despair because the Royal Astronomical Society of Canada has chapters all across Canada. So even if you're in BC or Saskatchewan, well outside of Ontario, you're in Quebec, there will be chapters near you. We just talk about the Toronto Centre one because, of course, we're in Toronto.
Right. That's true. That's true. Actually, moving west, you get darker skies and probably better viewing again.
Weather allowing, of course.
Weather
Yes,
alone.
and I will just say that as a final wrap up for, we did say the Allan I. Carswell Observatory calendars, they do go to support our operations. They make excellent Christmas gifts, but so does a RASC membership. So
Excellent.
if anyone needs any extra, I suppose, last minute holiday ideas. All right,
We do.
so Now we're on to the news section of the evening. This is where we move away from history and we talk about what's happening right now, actually. There has been some really, really cool news, literally and figuratively. So I'm going to start off with the most, I think, uh, headlining one first. Did you know that there was sugar found in an asteroid? Oh my gosh.
Oh my God.
So
Not good for
NASA,
diabetes, people. So,
well, I think this is the one that also had some very hazardous chemicals, so you wouldn't want to put this in your tea.
no.
But it's on December 2nd, 2025, which is just a few days ago, that asteroid Bennu that we got the samples back from, uh, well, astronomers and scientists and geologists have all been really, really busy analyzing the grains of the asteroid that were returned. The asteroid Bennu has continued to give us great amounts of clues, and this is three new papers that came out. So NASA put out a press release, and three different spacecraft papers were published in Nature Geoscience and Nature Astronomy. And for people who maybe don't remember, because it was a little while ago, the OSIRIS-REx was the spacecraft that brought back the samples, or I suppose returned the return capsule and then kept going. Um, so OSIRIS is the Origins Spectral Interpretation Research Identification and Security Regolith Explorer, which is a
Thank
terribly
God they got the acronym, right? So
well,
I was
this is
like,
a terribly complex name for making something called Rex that went and fetched an object because Rex is a very common dog name, and obviously they wanted to call it Rex because they sent it out to fetch an asteroid sample. So I think this is a an acronym that has been forced, but I'll allow it because it's a very cool mission.
oh,
So let me
there.
tell you a little bit about it. We've got some amazing discoveries that we weren't necessarily looking for in the chemicals and compounds found in these grains, in particular sugars, which are essential for biology. They found a gum-like substance, and not chewing gum, not before seen in astromaterials. And they found an unexpectedly high abundance of dust that seems to have been produced by supernova explosions, i.e., it's metal enriched. So it's not just hydrogen, helium. There's some metals in there. So starting with the sugars. Okay. This is a team led by Yoshihiro Furukawa of Tohoku University in Japan, and he found sugars essential for biology on Earth in the samples. So what does this mean for the asteroid? Well, not entirely clear, but what it does mean is that if these sugars essential for biology could be found in this asteroid, perhaps they were also found in other early solar system materials. The 5 carbon sugar ribose, and for the first time in an extraterrestrial sample, so outside of Earth, there was 6 carbon glucose. So chemists, time to get your your drawing out and start looking at the how the molecules fit together. This is added, so these are added to the list of building blocks for biological molecules. So how do molecules come together? Well, you need various different kinds of building blocks. The 6 carbon glucose, the 5 carbon sugar ribose, those are building blocks. And that's what they had already found in Bennu from before, is they knew that there was already amino acids, nucleobases, and carboxylic acids, which is I might be saying that wrong. So if this is true and this is a good sample, which it seems to be, there was a lot of very careful control over it, that means that these substances would have been widespread throughout the solar system when planets were forming. So maybe we can expect to find these things on other planets in our solar system. Deoxyribose and ribose are key components of DNA and RNA, respectively, which we do need for life, we think. Now, of course, DNA is the carrier of genetic info into cells. RNA performs many functions that are essential for life as we know it. Ribose in RNA is found in sugar phosphate as a backbone that connects a string of information carrying nucleobases. So, discovery of ribose means that all the components of RNA are actually in Bennu. So, you could make RNA if you could, paste the various components together from what is in Bennu. Ribose has already, I should say, been discovered in 2 meteorites that were found on Earth, which is less of a good discovery because, of course, it could have been contaminated, but it wasn't a huge surprise. No deoxyribose was found in the sample, so ribose may have been more common in the early solar system. So this evidence supports what's called the RNA world hypothesis, where first life on Earth would rely on RNA as a molecule for information storage and to drive chemical reactions. So if RNA is readily available, that's actually a good thing for forming life on Earth. Today, life depends on DNA and RNA and proteins. Earlier life might have been simpler. Well, earlier life definitely was simpler if you go back far enough. The sample also contained, of course, glucose, which a lot of us have heard of, a very important energy source, and indicating that glucose was actually present in the early solar system in some form. Now, about this gum. So the gum is not chewing gum, as I said. The
Yeah.
gum was discovered by a totally different team. This team led by Scott Sanford at NASA's Ames Research Center in California, and of course, Zach Gainsforth of University of California, Berkeley. They found this material in their samples, and this is the first time such a thing has ever been found in space rocks. It could have helped in the lead up to the emergence of the ingredients of life on Earth. And they think that this substance, which you're calling a gum, is, kind of a little bit sticky, I guess, because it's got polymers. So if you've heard of plastic polymers, well, you kind of have an idea of a polymer-like material. This could have been formed early in the solar system if Bennu was a little warmer, and then it got incorporated into Bennu. And polymer-like materials rich in nitrogen and oxygen, it would have been soft and flexible when it was warm, and as of course the solar system cooled and Bennu cooled, it hardened. So this gum is not quite what we think of as gum, but but still a flexible material, molecules that could have provided chemical precursors that helped trigger life, and if your parent asteroid gets warmed up, or if Bennu gets warm enough, um, the idea is, of course, that water-soluble compounds called carbamate can form, and they can last long enough to polymerize and form longer molecules that aren't water-soluble. So the fact that we can see some of this happening suggests that Bennu was warm enough to become somewhat of a watery environment at some point. Materials were deposited in layers on grains of ice and minerals, and of course, the polymer is bendy and dimpled, so there are some pictures online if you want to go find them. When pressure is applied, it's translucent, and exposure to radiation makes it brittle. So it contains some of the chemical groups as polyurethane, some of the same ones, but more randomly arranged, and the composition of elements is different from particle to particle, so it's not a uniform substance. Very, very interesting, though. Now, the last one, and this is the probably one of the coolest ones, I suppose, supernova dust. And this was discovered by a team led by Ann Nguyen's from NASA's Johnson Space Center in Houston. Found two different rock types, and she was particularly analyzing pre-solar grains, trying to learn more about where the parent asteroid formed and how geological processes altered it. They thought that the pre-solar dust would generally be well mixed as the solar system formed, but the samples they got from Bennu had 6 times the amount than any other material from space that's been studied so far. I mean, we haven't studied nearly enough space material, but this sample has 6 times the amount from anything else that we've studied before. So perhaps the parent body for Bennu, or the whatever it used to be, might have formed in a region of our protoplanetary disk with lots of dust from dying stars in it. That same team also found that Bennu's parent, whatever caused Bennu to exist, was heavily altered by fluids, but there are still pockets of less altered material in the samples. So Bennu is not a uniform object. So Bennu is all in the news again, thanks to these 3 exciting papers that have come out, and of course, made us all really, really interested in asteroids again.
That's exciting. It's, but is Bennu in the asteroid belt, or is it further inside? Like, where did they
Yeah, so
find?
Bennu goes in a little bit of a different, it's got an interesting orbit. So we like to use AU a lot in astronomy. That's the distance from the Earth to the sun. So 1 AU is 1 Earth-Sun distance. Bennu actually travels from about 1.3, 1.4 AU, so just a little bit farther than Earth, and then it goes inside all the way to about zero point 0.9 AU.
Oh,
So it
oh,
actually goes closer to the sun than Earth and then back out farther. And Bennu is an interesting one as well. Bennu is a strange object. If you go and look at a picture of it, it actually looks a little bit like a diamond or a child's toy top. It's got a diamond shape to it, and we could actually see material kind of flying off of it. It doesn't seem to have uh yeah, it doesn't seem to be well attached to itself, and it's low mass for an outer space object, so it's not so massive that it's caused itself to be round, which is one of the classifications that you need to have a planet. Um, it's a smaller mass object, and of course, being somewhat closer, it makes it an easier target to do a sample return from.
the reason I was asking that is because if it is within the Earth's orbit, right, could it have, like, let's say, few million years ago, broken off of Earth when plants were rampant, right? And the RNA
No,
presence of,
it's
because the
it's
poly,
not it's not well mixed enough for that. So if you have something like Earth or the Moon or Mars, there are certain things that you expect rocks that come off of those planets to do, which is one of the reasons why we can identify what we call Martian meteorites. So pieces of Mars that have gotten knocked off by a large collision and traveled through space and somehow managed to come to Earth, which we
like
think
a
we have.
meteorite. Yeah, like
Yes.
a meteor. Okay.
And we think we think we have, and we think we can identify them. Bennu, on the other hand, seems to be primordial, a primordial object, so something that was around since the formation of the solar system. It
Okay.
has obviously changed a lot over time, and due to its orbit now, it is inside what's called the ice line. So in our solar system, if you are water, you will be ice if you're too far away from the sun, which makes sense. You get too cold, you turn into ice, you're
Right.
basically a solid. But Bennu is close enough to the sun, roundabouts of the same position as Earth. And no, it's not going to collide with us, but it's warm enough to where water would not want to survive. It would want to melt away.
Hopefully, on a lighter side, when Armstrong went there, he didn't spit on it or anything like that with the chewing gum, right? So, right.
Oh, on the moon,
No,
I
on
believe,
Bennu
yeah. Well, Bennu,
with
the
the
only
gum.
thing that's been there is Osiris Rex. So they tried to prevent any kind of contamination as much as possible. And so Osiris Rex briefly touched down and grabbed a sample from the asteroid surface in 2020. So this was big news.
Yeah.
There's lots of videos about it. Definitely recommended. And then a capsule, which was had the sample in it, was returned and landed on Earth in 2023. So just a few years ago. Very, very exciting. There was a chase through the desert. They had a chase helicopter going after it. Um, Really, really exciting stuff. And of course, in Canada, we did get our little portion
Oh, we
of
did get a piece of
Bennu.
Bennu. Oh,
We
okay.
did, we did. And so, there it's under the control of various institutions who have the rights to certain amounts of grains of Bennu. Now they didn't return a huge amount because, of course, you have to be very careful with how much you get.
Right.
But
Yeah.
they were able to get about 120 grams, which is not a lot, but it's not nothing.
Yeah, that's
Um,
true. 100 grams is a lot. Yeah, no. Space sample, right? So it's amazing.
Yes, exactly. And this being able to do this kind of sample return is really, really useful because it's a lot easier to bring samples to Earth than it is to send humans out to the samples. It is very, very, very difficult to get humans into space. Just ask the Artemis program.
Yeah, the polymer is very exciting. The polyurethane you mentioned because it requires a lot of things to get together to form a polymer, right? And if they found that, right, that's amazing.
Exactly, and it does seem to indicate that wherever Bennu was in the early solar system formation was an interesting place, and had a lot of the building blocks for life that we need here on Earth. So it is kind of giving credence to certain um, theories for the formation of life on Earth. But it's still going to be, I think, a lot of analysis to pour over and to look at exactly how these polymer materials react. And of course, ideally, we would at some point be able to go back and get more samples from other asteroids and compare them.
Exciting.
So just put my last minute plug for more sample return missions.
That's true. Uh, I'm interested what Canada will find with the 100 grams of samples as well. Like it'll be exciting to see that.
Yes, and of course, I do have to say that since we mentioned sample return and we don't have a ton of time left, I will just say that there is a proposal to do sample return from Mars, which, as life on other planets enthusiasts will know, has long been a favorite topic for a possible location for anything else in the universe to be. But a Mars sample return mission has actually been proposed, and a few times people have tried to come up with ways to bring any bits of Mars directly back to Earth. The Mars 2020 mission landed the Perseverance rover, which I think some of you may have heard of, and they have been taking rock samples. So there's, I think, as of this year, there's something like 43 rock samples that have been left on the Martian surface. with sample tubes. I think
Oh.
there's yeah, 43 sample tubes have been filled. That's correct. There's no way to bring them back yet, but there are a lot of proposals to bring them back. So, if anyone has any ideas, I guess you can send them to NASA.
Low gravity, throw it out from there, right? So hopefully make it.
Exactly. All right, so I think we have to end off for the evening here. Thank you so much, Mahesh, for being on the show with me this evening.
Thanks for inviting, Elena. It was a pleasure and beautiful pictures, especially the Stevens Quintet. I wanted to see that, and amazing pictures coming through on the uh, on the on the Zoom link, right? So on the YouTube.
Yes, absolutely. Anyone who wants to catch those wonderful views, they're all recorded on YouTube. So even if you missed it live, you can always go back. All right, so I'm going to just take a moment and thank everyone. You have been listening to York University Astronomy and Astrophysics program, written and presented by students, faculty, alumni, and friends of York University. The host this evening has been myself, Dr. Elena Hyde, and I'm joined by a special guest, Mahesh Aravamudan from Rask Toronto Centre, and of course, a wonderful astronomy enthusiast who has helped me explore all kinds of fun things out there in the universe this evening. You can always connect with us on Instagram, Facebook, or PixelFed. And of course, check out our website for show notes, content updates, that wonderful donate button, or the new calendars at yorku.ca/science/observatory. Thanks for tuning in to York Universe. Clear skies, everyone, and have a good night.
Good night.